Hello and good day everyone. So this is the last part of this chapter, which is we are going to finish the absolute values. Okay, the learning outcome for the first part will be at the end of the lesson students are able to solve absolute inequality of the form. So for the first part we are going to focus on the number 2, which is the absolute of ax plus b less than absolute of cx plus d, and the fourth part, which is absolute of ax squared plus bx plus c is less than d. So this notation also apply for all the inequality notation, which is less than, more than, less than or equal, and more than or equal. For the second part, we are going to discuss on the rational absolute inequality. So this rational will take a long time lah. Okay, for the first part of this lecture, we want to solve the inequality of absolute value with both sides contain the modulus notations. For example, 1. Solve the absolute of x minus 3 more than or equal to absolute x 2x plus 5. So we have both modulus on each side. Okay, so how to solve for this one? So we can either apply the basic definition, but for this one we can directly use the squaring both sides. Why? Because we have the modulus on both sides. So if we square the both sides, so what we can do, we can just directly expand. So that is the first method. You can either expand as usual and then we get the quadratic and then we solve the quadratic. But another method is to apply the formula of a squared minus b squared. How? By bringing the right side to the left side, so it will be x minus 3 squared minus 2x plus 5 squared. So this is our a, this is our b. So what is a squared minus b squared? It actually can be written in a form of a minus b multiplied with a plus b. So we transfer from a squared minus b squared into this form. So what is our a? X minus 3 minus b. So x minus 3 minus or either one, mana-mana dulu, minus dulu boleh, tambah dulu pun boleh. So for this one, they use the positive first. So what we can do, it will be x minus 3 plus with 2x plus 5, a plus b, and then x minus 3 minus 2x plus 5. So it will be minus 2x minus 5 more than or equal to 0. So we just have to solve in each of the bracket. So what we get on the first bracket, x plus 2x will be 3x, and then negative 3 plus 5 will be positive 2. This side, x minus 2x will be negative x, negative 3 minus 5 will be negative 8. So both of these is a factor, linear factor. So it is easier, then we just expand and then rearrange and factorize again. So directly from this part we can solve by using the graphical method. That is the easiest one. But before that, imagine we have the negative sign here. So normally we didn't deal with this negative sign. What we can do, we can factorize. It will be 3x plus 2 multiplied with a negative of x plus 8. So more than or equal to 0. So negative, how to eliminate this negative? We multiply with negative 1 on each side. So if we multiply with negative 1, this negative will be positive. This one, 0 multiplied with negative will be 0. But what we change is the sign here. So that's why we have 3x plus 2 multiplied with x plus 8 less than or equal to 0. Okay, this is the simplest way to make sure you didn't do any careless mistake. Please take note. So solve it by using the graphical method. So we have a small function and we have a root of x equal to negative 2 over 3 x equal to negative 8. So this one is smaller, so it should be on the left side, and then this one will be on the right side. And then we have the question want you to find the negative value, which is should be below the x-axis. So this one is when y less than or equal to 0. So the area will be in between negative 8 to negative 2 over 3. So this will be the answer. So write down the answer in solution set. This is the solution set. So you can give either one if the question didn't ask which form they want as the answer. Okay. Example 2. This one also have both modulus on each side. So what we can do, we can square both sides, and then we can directly apply the a squared minus b squared form. So it will be, this is our a, this is our b. So it will be x minus 2 plus with 2x plus 3 and x minus 2 minus 2x plus 3. So it will be minus 2x minus 3. So simplify on each bracket. What we will have is 3x plus 1 multiplied with negative x minus 5 less than 0. And then the next step is, remember we have this negative sign. What we should do, we have to make sure the coefficient of x always positive. So factorize, it will be x plus 5. So the changing in the sign, don't forget, so it will be 3x plus 1 multiplied with x plus 5 more than 0. What is the next step? Yes, this is a quadratic, so we use the graphical method. The easiest way is to use the graphical method. So we have a root of x equal to negative 1 over 3 and x equal to negative 5. So which one should be on the left? Yes, negative 5. And then on the right will be negative 1 over 3. So it's one function. So which area? We want the more than 0. So it should be on the top of x-axis. So the arrow will be on each of the roots, each side of the root, which is less than negative 5 and more than negative 1 over 3. So the answer can be written in the form of interval from negative infinity to negative 5 union with negative 1 over 3 to infinity. Or in the solution set form, it will be a set of x such that x is less than negative 5 or x more than negative 1 over 3. Okay, so we skip to the fourth part. So we are going to discuss the third part on the second part of this lecture. Okay, the fourth one is the inequality of absolute value with quadratic on a side. So means that the quadratic contain the absolute notation. So the other one will be anything. So what we can do, we just have to apply the basic formula, basic definition. So for this one, x squared minus 5x plus 3 is less than or equal to 3. So how we do for this one? So remember the basic definition, absolute of x less than or equal to, it should be in between. Okay, so write down by using the basic definition, what we will have is negative 3 is less than or equal to x squared minus 5x plus 3. So this is our a, right? So one side will be negative a. So that's why we have negative 3. The other side will be 3. Can we solve for this one? Okay, if we see here, we cannot solve it because we have x squared and x. So two terms that contain x. So what we can do is to solve for one side and then the other side. We can separate into two inequalities. So the first one will be x squared minus 5x plus 3 less than or equal to 3. And then the second one is negative 3 is less than or equal to x squared minus 5 plus 3, or So reverse, we swap between these two, so the sign will be changed. So it will be x squared minus 5x plus 3 more than or equal to negative 3. Why we need this n? Because the answer should be satisfy both of these inequality. If not, it cannot satisfy the original questions. So that's why we have this n notation. So n notation here means that it will be intersection between the two solution. Okay, so this n is important for the final answer. So what we can do, we can solve for each side. So the first side, x squared minus 5x plus 3 less than or equal to 3 will be what we should do for the quadratic. Yes, make sure the right hand side is equal to 0. So bring the, or subtract 3 on each side. We will have x squared minus 5x less than or equal to 0. And then we don't have any constant here, means that we can factorize the x here. So what we have is the factor is x multiplied with x minus 5 less than or equal to 0. So we have to factor here a quadratic. The first one will be x equal to 0, another one x equal to 5. So what we should do, yes, we can sketch the graph. Okay, sketch the graph. So what will be? So this one will be 0, this one, the other side will be 5. So 0 is less than 5, and then it's a small graph, and then what we want is the less than or equal to 0, which is the negative part of y, so below the x-axis. So the first part, the answer will be in between 0 and 5 inclusively, okay, because we have the equal sign. And then solve for the right hand side, for the right part. So x squared minus 5x plus 3 more than or equal to negative 3. So what we can do, we add up 3 on each side. So we have x squared minus 5x plus 6 more than or equal to 0. So quadratic, solve, factorize the quadratic expression. What we have is x minus 2 multiplied with x minus 3 more than or equal to 0. So we have a root of x equal to 2, x equal to 3. So this is a small function, so sketch the graph, a small function with roots of 2 and 3. And then what we want is the graph with more than 0, positive, so above the x-axis. So what we have as the answer is from negative infinity to 2 inclusively, union with 3 inclusively to infinity. Is this the final answer? No, we still have this notation of n. What we should do, we have to find the intersection between these two sets. So how to find intersection between two sets? We have to sketch the real number on the real number line. So this is our real number line. What we have as the value, we have 0, we have 5, and then we have 2, we have 3. So label on the real number line 0, 2, 3, 5, and then draw the number set on the real number line. The first set is 0 to 5, so it will be inclusive 0 to inclusive 5. So connect the dot. So we have this line for the first set, and then for the second set is from negative infinity to 2. So it will be dense dot on the 2 to the left, and then from the 3 to the right. So where is the intersection area? We want to find the intersection area. So find the overlapping area for both sets. So we have this as the answer. So it will be overlapping in these two areas. So the answer should include these two areas. The first one will be from 0 to 2. The second one will be 3 to 5. We can give the answer in the form of interval, which is 0 to 2 inclusively, union with 3 to 5. Both are inclusive. Okay? Okay, that's all for this part. Let's continue with the second part, which is the most important, absolute inequality.